Find the value of a and b for which the following system of equations have infinitely many solutions. So we have two equations. This is equation 1 and this is equation 2. These equations have got many solutions, which means they are coincident lines. First we've got to find what is a1, a2, b1, b2, c1 and c2. For a1 is coefficient of x, so it will be 2a minus 1. b1 is coefficient of y, so it will be minus 3. And c1 will be 5. Now a2 will be coefficient of x, that is 3. b2 will be coefficient of b minus 2. And c2 will be coefficient of 3. Now here the equations have infinitely many solutions. So we write here equations have, for infinitely many solutions, the condition is a1 over a2 equals b1 over b2 equals c1 over c2. Now to put the values, we know our a1 is 2a minus 1, b1 minus 3. No, I need to put a2 there, which is plus 3. Then b1 is minus 3, b2 b minus 2, c1 5, and this is 3. So here's the equation again. Now what we will do is we will take up 2a minus 1 over 3 and 5 by 3 and equate them, equal to 5 by 3. We cross multiply, or we can even take 1 by 3 common out. If we take 1 by 3 common out, we cancel the 3 on either side. So we have 2a minus 1 equal to 5, 2a equal to 5 plus 1, 2a equal to 6. So a equal to 6 by 2, a equal to 3. Now to find out b, I'm going to take minus 3b minus 2 and 5 by 3. It becomes easier. So minus 3 over b minus 2 equal to 5 by 3. Now cross multiply. So minus 3 into 3 equal to 5 here, b minus 2. So minus 9 equal to 5b. 5 into 2 is 10, so minus 10. So minus 9, I bring the minus 10 on the side, becomes plus 10 equal to 5b. So 1 equal to 5b, and your b is 1 by 5. So for your answer, a equal to 3, b equal to 1 by 5. Now again equation 1 for the next sum, and this is equation 2. They also have infinitely many solutions. So as a standard, we need to find the a1, b1, c1, a2, b2, c2. So this will be our a1. Coefficient of y is b1. This would be our c1, that is 12. Now for a2, coefficient of x is a plus b. So a plus b is a2. Coefficient of y is 2a minus b. And this would be our c, 5a minus 1. These equations also have infinitely many solutions, and if that's the case, we know a1 over a2 equal to b1 over b2 equal to c1 over c2. Now let's put the values. Our a1 is 3, a2 a plus b, b1 is 4, b2 2 over a minus b, c1 over c2 will be 12 over 5a minus 1. Here we could reduce it. 1s are 2s are. So now again I write it, and you will have 3 over a plus b equals to 2 over a minus b equals 12 over 5a minus 1. Now we need to make two equations. So first we will take up these two. We will take up 3 over a plus b equals to 2 over a minus b. We now cross multiply, so we have 3 into a minus b equals 2 into a plus b, open the bracket, 3a minus 3b equal to 2a plus 2b. Bring all the a's together, so we have 3a minus 2a, bring all the b's together, minus 3b minus 2b equals 0. Now 3a minus 2a is a, minus 3b minus 2b is minus 5b equals 0. I'll put this as equation 3 in fact. Okay, now we take the other two parts, so we take now these two, which is 2 over a minus b equal to 12 over 5a minus 1. Cross multiply, 2 into 5a minus 1 equals 12 into a minus b. Open the bracket, 2 into 5, 10a, 2 into minus 2, minus 2, 12 into a, 12a, 12 into minus b, minus 12b. Bring all the a's together, 10a minus 12a, bring the b also on the side, so minus 12b becomes plus 12b, minus 2 becomes plus 2. So 10a minus 12a is minus 2a plus 12b equals 2. I can take now 2 common out. So if I divide this by 2, I get minus a, divide by 2, 6b, divide by 2, 1. So my equation, ignore the 2, minus a plus 6b equal to 1. So this is now my equation 4. Now I take both these equations and write them one below the other. So I add the equations up, add 3 and 4. So I have a minus 5b equals 0, and here minus a plus 6b equals 1. Plus a minus a will cancel out, and minus 5b plus 6b will be 1b equal to 1. So the b equal to 1 over 1, which is 1. So I got the value of b. Now I got to find the value of a. To find the value of a, I'll put b equal to 1 in any one of the equations. Say equation 3, that is a minus 5b equal to 0. A minus 5, b we know is 1. Here we put the value of b as 1. We found it here as 1. So this is equal to 0. So a minus 5 equal to 0. So a equal to 5. So your answer, b equal to 1, a equal to 5. This is equation 1, and we have equation 2, and they have infinitely many solutions. The first equation is written in order, but if you notice in the second equation, you have a y term out here and you have a y term out here also. So we need to put the y terms together. So what we do is we do 2ax, put the y terms together, so ay, the minus by will come on the side, plus by, and this becomes 28. So 2ax, now we'll take the y common out. Here is a y term, here is a y, and we'll take the y common out. So on taking y common out, you will get a plus b equal to 28. Now our equation is ready. So I'm going to write the equation out here, one below the other. So 2ax plus a plus by equal to 28, and this will be my equation 2. Now we need to identify a1, b1, c1, and here a2, b2, and c2. So here is our a1, we will put as 2. This is our b1, we put it as 3. This is c1. In the other equation, the coefficient of x is a2, so this is 2a. Coefficient of y is b2, a plus b, and n 28. It has infinitely many solutions. And for infinitely many solutions, we know a1 over a2 equals b1 over b2 equals c1 over c2. Let's go ahead and now substitute the values so that we get now here 2 over 2a, that is a2, b1 is 3 over a plus b equal to 7 over 28. Here we can reduce this. So what we will do is reduce 1s and this is 4s. So we can now write it again, and here 2 we can reduce. So we have 1 by a equal to 3 over a plus b equal to 1 by 4. In our first equation, we will take these two terms, these two parts, and solve them. So 1 by a equal to 3 over a plus b. In fact, we could do it easier. What we could have done is, we could have taken this 1 by a and 1 by 4. It would be so much easier to calculate. Suppose 1 by a equal to 1 by 4. You cross multiply, you a equal to 4. We got it very easy. Now in the next part, we will now take 3a plus b and 1 by 4. So we take 3 over a plus b equal to 1 by 4. Cross 3 into 4 equal to a plus b. 12 equal to a plus b, and we already know that our a is 4. So here we'll do a plus 4. So a equal to 12 minus 4, a equals 8. So for my answer, a equal to 4, here b equal to 8. Because I already know my a, I'm finding here my b. So this part is not right, what I've done. So I need to do my now a. I'm substituting for a. My a is 4 plus b. So what I'm actually finding out is b. For the fourth sum, this is equation 1, and here I have equation 2. My equation 1 is written in proper standard order, x plus 2y equal to 1. But my equation 2 needs to be rearranged. So I first open the bracket. A I multiply into the bracket, so I get ax. A into y is ay. This becomes minus bx minus b into plus by equal to a plus b minus 2. Now I bring all my x terms together. This is my x and here is my x term. So I will get now ax minus bx, and I get my b terms together, the y terms together. This is y term and here is the y term. Put them together, so I have plus ay plus by equal to a plus b minus 2. I'll now take common out. I will take x and x common out here. So when I take x common out, what remains is a minus b, and in the other I'm going to take the both y terms, so I will take y common out, so plus y, what remains is a plus b equals to a plus b minus 2. Now my equations are ready, so I need to find out what is a1, b1, c1, a2, b2, c2. So if you see here, the coefficient of x is 1 here, so a1 is 1, coefficient of y is 2, so this is 2, c is 1. In this case, this is coefficient of x, so I put here a minus b, coefficient of y a plus b, and this is my c term, that is a plus b minus 2. They have infinitely many solutions. And if they have infinitely many solutions, my condition is a1 over a2 equal to b1 over b2 equal to c1 over c2. So our a1 we know is 1, a2 is a minus b equal to b1 is 2, b2 is a plus b, c1 is 1, and c2 is a plus b minus 2. We'll now take up these two terms and cross multiply. So I have 1 over a minus b equal to 2 over a plus b. On cross multiplying, I will get a plus b equal to 2a minus b. On opening the bracket, I get a plus b equal to 2a minus 2b. Bring all the a terms together, a minus 2a. The b terms together, 2b equals 0. So I have minus a plus 3b equals 0. I'll put this as equation 3. Now to find the other equation, I take the other two parts. I will take these two. So I will write here 2 over a plus b equals to 1 over a plus b minus 2. On cross multiplying, 2 a plus b minus 2 equal to a plus b. Open the bracket, 2a plus 2b minus 4 equal to a plus b. Take all the a terms together, 2a minus a plus 2b minus b, and the 4 on the other side becomes plus 4. 2a minus a is a, and here we have b equal to 4. So this becomes equation 4. Now I will take up these two equations and put them one below the other. So basically I add the equations up, add 3 and 4. So I have minus a plus 3b equals 0. A plus b equals to 4. I cancel this, 3b and b is 4b equals to 4, b equal to 4 over 4, b equals 1. To find the value of a, I will substitute b equal to 1 in any one of the equations. Let me take the fourth equation, which is given a plus b equal to 4. A plus, we know my b is 1, so I put here 1 equal to 4. So b, my a, not b, a will be equal to 3. For what value of k the equations are inconsistent? Inconsistent means they have no solution. Here this means no solution. And you know the condition for no solution, a1 over a2 equals to b1 over b2 not equal to c1 over c2. So here we need to write our a1, b1, c1, a2, b2 and c2. Now your 4 will be your a1, here 6 will be your b1, and this will be your c1. For a2 this will be 2, b2k, c2 7. So they said they're inconsistent. Inconsistent means no solutions, and for no solution the condition is a1 over a2 equals to b1 over b2 not equal to c1 over c2. So that is 4 over 2 should be equal to 6 over k not equal to 11 over 7. So we will take up the first 4 over 2 equal to 6 over k. So if 4 over 2 equals 6 over k, we have 2 equal to 6 over k, and the k will be equal to 6 over 2, k will be equal to 3. So if k equal to 3, it has no solutions. For what value of k the equations are coincident lines? So back again here we need to find what is our a1, b1 or b2. So for a1 here will be 1, for b1 it will be 2, for c1 plus 7, for a2 will be 2, for b2 coefficient of k, that is coefficient of y, that is k, and this is 14. Now the lines are coincident. Coincident means they fall one over the other, or the lines have infinite solutions. So the condition for this a1 over a2 equals to b1 over b2 equals C1 over C2. Now when we put the values, we have 1 over 2 equal to 2 over k equal to 7 over 14. So we can take any of them. We'll take 2 over k equal to 7 over 14. 7 over 14 is 1 by 2. So you have 2 over k equal to 1 by 2, cross multiply, 2 into 2 equal to k, so k equal to 4.